So let's go over 19.2, permutations and probability. In Explain 1, we're going to go over finding probability using permutations. So I took this from your textbook. Essentially, it says permutations can be found by the number of permutations of n objects taken r at a time can be given as n sub n p r, and we can use this formula to figure it out. We are going to be using our Desmos calculator just to help us out. It's not going to be the graphing one, it's going to be the scientific one. And I'll show you how to use that later. But just so you know, permutations is, let's say we have a couple of things in order, like the numbers 1, 2, and 3. And I want to count up all the different ways I can write 1, 2, and 3. So this is one way. I could also change the order because order does matter for permutations. I can change the order of the 2 and the 3. I can make, instead of 1 coming first, 2 go first, and change that order around for 2 to go first and 3 and then 1. So it's a couple more. Let's say if I wanted to have 3 go first and then write 1 and 2, or 2 and 1. So permutation is just the different ways I can order stuff. Change in order, where order of items or numbers, whatever it may be, matters. Okay? Kind of like in a race, right? It matters who's in first, who's in second, and who's in third, right? So just so you know, that's one of the examples for permutations. All right. Let's go into Explain 1. They say, let's say there's a research lab and it requires a 4-digit security code. So if order ever mattered, definitely in a security code or password does matter. There's a number of digits that they have to choose from: 0, 1, 2, 3, 4, all the way up to 9. And no digit can be repeated, so that's really important. So I can't have like a password where it's like 9999. That's not allowed. That's what it means by no repeats. It says, what is the probability that a scientist is randomly assigned a code with the digits 1, 2, 3, 4 in any order? Okay, so let's go over that. So first things first, let's figure out how many total numbers there are to choose from. Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 numbers. How many digits are in our security code? 4. I will on our Desmos calculator show you how to calculate that, but for now let's go ahead and figure out what our event A is going to be. So this is event A consists of permutations with the security code of either 1, 2, 3, or 4. So here, how many total numbers are there to choose from? Here, 4. And again, what is my passcode have to have? 1, 2, 3, or 4 numbers? 4 as well, just like that. So I'm going to show you how to calculate a value for our sample space. That's what S stands for, by the way. For our event A, and then we're going to figure out the probability of that. So we're going to open up Desmos.com. I'm going to click on the scientific calculator, and you'll see there's a bunch of functions on here. I'm going to go to the word function key, and you can see I have that button for n permutation r. So I'm going to click on that and write in 10, comma 4. And that's about 5,040. Wow, that's a lot of different codes. That's a lot. All right. Let's go ahead and figure out, if I only have 4 to choose from and I still need a 4-digit password, how many different ways there are for that permutation. 4, comma 4. Oh, that's a little less, 24. All right, and then if I wanted to put this in a fraction, so I'm going to write in on, I'm going to go back to main. I want to put this in a fraction of 24 because that's my event A, and 5040. Yes, I do get a decimal, but I can also reduce and get 1 over 2/10. So we're going to record some of these values here on our paper. This is a great tool to use, not only for homework, but also on your practice tests and tests, so make sure you are using it. Okay? So on the previous screen, all I did was I recorded all the values we found on our Desmos calculator. 5040 was for our sample space, 24 was for our event A. We put this as event A over sample space, and we reduced that, and we got our probability to be 1 out of 210. That's a lot. Alright, let's go ahead and move on to part B. Let's say a certain motorcycle license plate consists of 5 digits chosen at random, so 5 digits. No digit can be repeated. Just so you know, whenever you see a digit problem, there's only a certain number of digits to choose from. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So whenever they use the word digit, this is what you can choose from. No digit can be repeated, so you can't have something that's like 1, 1, 1, 1, 1. That's a definite no-no. That's what they mean by not repeated. Alright. And this is, what is the probability the license plate will have all even digits? Ooh. Alright. So first, sample space. They want 5 digits. So 5 digits. Out of how many total digits do I have to choose from? Count them up. 10 digits. So that means it's going to be my total of 10 out of 5 that we need. Okay, so I'm going to go ahead and kind of skip this part so we can calculate it right out. Event A is that my license plate will have with all even numbers, right? Because that was in our question, all even digits. So again, how many do I have? I can only choose a total of on my license plate. Total on my license plate is a total of 5 digits. Out of all these digits here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, how many of them are even? Well, there's 2, 4, 6, 8. That's about 4 of them. Again, let's go ahead and calculate that out using our Desmos calculator. Alright, so again, using our Desmos scientific calculator, let's go ahead and write function. That's going to be, again, our permutation, which is down here. Let's go ahead and put 10, 5. And that's, wow, that's a big number. 30,240. Wow. That's a lot of different combinations. Permutations. Alright, again, we'll find permutation of 5, 4. Oh, not too bad, 120. Alright, and last but not least, let's go ahead and go back to the main function, and let's go ahead and reduce 120 over, wow, 30,420. We will get a decimal. We can change that to a fraction. Ooh! 2 over 507. Oh, my bad. Let me go ahead and change that. So that should be 30,240. Wow, we got a very different answer there. So just make sure that was actually a lesson. Make sure you're entering stuff in correctly. Alright, let's go ahead and record this back onto our paper. So we got for the first one, 30,400 and, oh, see, I was about to make that same mistake. 30,240, 120, and this is the probability of all even digits. And we got 120 over 30,240. 240, which reduces to 1 over 252. Just like it says here on the bottom of the screen, and in your packet, stop! Do the problems in your packet for Explain 1. We'll be back with Explain 2 in just a moment.